Okay, today we're going to work through prime factorization and prime and composite numbers.
Were you telling me to be quiet?
No.
Okay, just checking.
I could. Okay, first definition, prime numbers. Prime numbers have only two factors, one and itself. That is what makes them prime. This is not, oh, we didn't hand out the package yet. Guys, we're on page 10 in your modules. Sorry about that little snafu. On page 10, who thinks they know the answer to number 1? Raise your hand. Okay, Madison, what'd you write? Thank you. Okay, one key note. When I write 10 times 3, do I put an X, Micah? No. Why not? Because what is X? X is a variable, so I do not use the X anymore, right? Okay. Really quickly, did anybody else have a different answer to number 1? Emma? Guys, no one should be talking right now except me and whoever's raising their hand. Yes, Emma.
Are you able to do 3 times 10?
So you wrote it as 3 times 10?
Mm-hmm.
Like this? Oh, okay. Did anybody else write something different? So we only have 2 options, right? So everybody here should have one of these 2. Bella, did you have something else? Okay. So, quick raise of hands. How many of you wrote this as 10 times 3? Raise your hand. Oh, wow, almost everybody. Okay, hands down. How many of you wrote this as 3 times 10? I hope you guys realize who's raising their hand in the center of the room. Miss McShann is, or isn't she? Does it matter which way I write this?
No.
Yes, it does.
What?
Yes, it does. Is my answer the same? Yes. So the answer is the same. However, my modeling is completely different based on how I wrote this. If you wrote this as 10 times 3, you are wrong. When I write multiplication, and Ms. McShann actually added this, if you guys look at this, what it's saying is the first number is telling me how many groups of the second number I am adding together. So, in this case,
So 3 groups of 10.
oh, so, guys, listen up. My back tables, you guys need to be quiet. For those of you that did this, here is what you actually wrote. Does that look like this? No, it does not. The answer is the same. Commutative property of multiplication. From that, I can multiply them in any order and get the same answer. However, when I am modeling this, there's only one correct answer. That is 3 times 10, because it's 3 groups of 10. Go ahead, Kendall. Okay, so now that we've got that straight, let's try number 2. What did you write for number 2? Osana? 7 times 4. Did anybody else write something different? JJ? Thank you for being honest. 4 times 7. So, we now know, hopefully, which one it is. So, regardless of what you wrote down, if you think this should be written as 7 times 4, raise your hand. Okay, hands down. If you think this should be written as 4 times 7, raise your hand. I appreciate the confidence. Good job, Luna. Okay. No, guys, this is 7 groups of 4. 7 times 4. This is the correct answer. This is wrong. Okay. Our next one, 8 times 2. Okay, Carter, how do I write this one? Carter? You didn't write anything down on your paper? Okay, JJ, what did you write? You didn't get to number 3? Which is? Oh, it's 16? No. You're supposed to rewrite this as repeated addition or as multiplication. Krista? So you actually wrote that many 2's out? Wow. So she wrote out. Hold on, guys. Did anybody else write something different? Bella? Good, thank you. I was hoping someone would say that. Nora. Okay. Did anybody else have something different? Did anybody else have something different? Okay, how many of you wrote all those strings of 2's? Raise your hand. How many wrote it with all those 2's? Okay, hands down. How many of you wrote it as 8 plus 8? Okay, those of you who raised your hand the second time are wrong. It's 8 groups of 2, so it's 2 plus 2. Krista got it right on the nail. Okay, our next one, 3 times 9. Madison? Okay, we're going to stop there because I think you guys are getting the idea. That is the correct answer, right? Now, what happens when we throw a variable in? Does that change anything? No, it doesn't. Micah? What? 6 times m is like m 6 times? No way. Whoa. We are getting into some deep thinking in math today. Thank you. Guys, really quickly, listen up. This is really, really important because we're actually getting back to what you have in your notes in Module 1, which I basically could bet anything, none in here is going to have this. When I have a multiplication algebraic expression like this, this number now has a special name, a special math term. Who remembers that math term? No. No. The number has a vocabulary word associated with it. Aaron? No. Good guess, but the equation has to have an equal sign. No, the variable is the m. So in this expression, the m is my variable. What do we call the 6? What is the mathematical term for it? Right? No. No. Guys, listen up. Okay, since everybody has forgotten, we're going to add this to your notes again. This is called a coefficient.
Yes! That's what I want! But I forgot it because I don't want to say it.
This is the numerical portion. of an algebraic multiplication expression. Okay? So this is basically saying this is the number piece. If I'm writing a number and a variable as a multiplication, the coefficient is the number piece. So that being said, could I ever write this as M6? I could? So model that for me. How many sixes am I going to add?
You can't. You don't know what M means. Well, you don't know what M.
I don't know what M is. I can't write it that way, guys.
M is.
Why can't I write it that way?
Because you don't
Hold
know
on.
the number of M.
Only one person has their hand up. Micah? M is a number. I just don't know what it is.
No, you just kind of know you just didn't. Keep going.
So like if you do M6, like what's the number that you have to write 6 down that many times?
Because I don't know what that number is, right?
Yes, you can't do it.
So I can't do that. So can I write as, mathematically, could I write this as M6? No. I have to write the coefficient first. The number always comes before the variable. Why? Because when I model this, can I model 6M? Yeah, I just did it. It's M added 6 times. Can I model M6? No, because I don't know how many times I would add 6. So why does my coefficient come first? Because it's the only way I can model that expression. Does that make sense? Okay, so all that being said, who now thinks you understand what you should write for number 6? Kaylee?
It's not related to what we're talking about.
So answer. How would I write part 6 now? How would I write number 6? Do what? Luna? 5D. Well done. Guys, listen up.
I didn't know what
2 other pieces on this. Listen. 2 other pieces on this. Do I write this as 5.D? No. Do I write this as 5xd? No. Okay? These are not appropriate ways to write it. This would be at least acceptable, but when I am multiplying a number and a variable, I just write them side by side. That tells me I'm multiplying. Make sense? You guys understand this exercise we just went through? Because this is going to become very important when we do exponents next class. Okay, that being said, let's turn to the first page in the packet we just handed out.
This is so hard.
Guys, please stop talking every time he takes a breath. It's really rude and annoying.
Yes, Madison.
What does
D? A D? Guys, seriously, today I don't know what's going on, but you got to stop. So the question was, if I have 5D, what does the D mean? The D just stands for a number. I don't know what the number is. No, not denominator. It's some random number. It's not technically a random number. There is a number there that I have not yet given a value to. It's just a placeholder. It's saying there is a number here. I don't know what it is yet. Okay. Everyone should be on this page. Let's stop talking so that you can listen. Let's talk a few of these definitions. First is a prime number. A prime number has only 2 factors, 1 and itself. Okay? This is where our 4 key numbers come in. Who remembers our 4 key numbers? 2, 3, 5, 7.
If you can't times anything to get to it, which is technically a prime number.
So let's talk about a couple other numbers really quickly. If I have the number 0, what factors do I have to get 0?
It's any number.
Technically, it's any of them, right?
Yeah, because 0.
Okay, because 0 is kind of special because it has no value. So there's nothing I can do with it. So 0 is neither prime or composite. So 0 is kind of a special number. It is not a prime or a composite. What about 1? What are the factors of 1?
1 times 1.
1 and 1. Does it have a second factor?
No.
No, it only has one factor, 1. So because 1 only has one factor, it actually falls in that same category as 0. So 1 and 0 are neither prime nor composite. So they don't fall into either one. Now let's take a look at some of these numbers and their factors. What factors can I multiply to get the number 5? 1 and 5. Are there any other factors? No, that's what makes it prime. What factors can I multiply to get 17? Do you have a packet? One and 17. Are there any other ones? Nope, that's it. What about 23?
23, 1.
You guys noticing a pattern here? Now, let me point out a second pattern to you guys. Can I divide 17 by 2, 3, 5, or 7? No, that's what makes it prime. Because I cannot divide it by 2, 3, 5, or 7, that makes it a prime number. What about 23? Can I divide 23 by 2, 3, 5, or 7? No, that's what makes it a prime number. Does that make sense? Okay, now let's talk about composite numbers. For a composite number, it means there are more than 2 factors. Could be 3 factors, it could be 4 factors, it could be a lot of factors. Okay? So let's look at some numbers. 12, what numbers could I multiply to get 12? I'll give you guys a hint. You should always start with 1. So 1 times what is 12? 12. So 2 factors of 12 are 1 and 12.
3.
What about 2?
6.
2 times 6. What about 3?
4.
3 times 4. So those are all factors of 12, making it a composite number, because there are more than 2 that will multiply to get it. Trosmos, I have an awful lot on the board that is not on your paper. This is not good. Okay, what about 15?
1.
Thank you. Someone listened to me. So we can do 1 and 15. Can I do 2? 3? 3 and 5. Any other ones on that one?
No.
No, that's it. What about 24? Good. 1 and 24. 2 and 12. What about 3? 3 and 8. And then 4, 6. Is this making sense? Do you understand the difference between a prime number and a composite number? Do you understand how 2, 3, 5, and 7 point you to the prime numbers and the composite numbers? If I can divide by one of those 4, it's composite. If I can't, it's prime. Basically all it is, guys. But just to be safe, here's where, if you notice the directions today, it said you need a highlighter or a colored pencil. Pen won't work because you need to be able to see through it. So if you do not have a highlighter or a colored pencil, go grab one out at the student desk. Make sure you grab a color you'll be able to see through, guys. Okay, first thing we need to do, hopefully you still have your pencil. We're going to cross out the 1. Why? Because 1 is not prime or composite. It goes into kind of a special category. It's neither prime nor composite. So we're marking it separately from everything else. Now grab your highlighter. And according to our chart, we are going to color all even numbers except for the 2. So what it's saying, guys, is basically I'm going to go all the way down the line of 4s, all the way down the line of 6s, all the way down the line of 8s, all the way down the lines of 0s, and everything in the 2 except for the 2 itself. So we're cutting out almost half of our numbers just on the 2s. So you're highlighting or coloring in all of these different columns. I do realize you guys aren't as fast or as good as I am at coloring, but that's okay. Of course I did. Okay? Again, make sure it's neat so that you can read it. You're coloring in all of these multiples of 2s.
Go in the line. Stop going out.
Really, Katie, stay in the lines.
I don't have any passion for this. That's why it's not working that well.
I thought you enjoyed art. This is basically art. Yes?
Yeah, in the lines all the way.
Deanna, come on. Okay, we're ready for our next step. So we've done number 2. Number 3, we're going to color in all the multiples of 5. So we've already done the 10s as part of 2. But basically we're saying color in everything except the 5 in this middle row. So we're basically just finishing off this middle row. Use the same color, just keep them all the same. Because different colors would actually just mess you up. Well, you're already messed up, Kent.
I know I messed up already. Fine, there you go.
No, you're doing just fine. You actually have improved a bunch this year, Kaylee.
What about?
That one should have been quick, because all you did was color in that middle column. So we've now done number 3. Number 4, color in all numbers. Guys, listen, this is a really important one. Color in all the numbers that are multiple of 3 except for 3. Here is your rule for checking divisibility by 3, guys. All I need to do is add the 2 numbers together. If that number is divisible by 3, then the whole number is. So I'm just going to go through this. I'm going to be talking relatively quickly, but that's all I'm doing is adding the numbers together to see if I can divide it by 3, to know if I cross it off. So 9 I should already know. That one goes. We're only looking at the ones that are still white because we need other ones to cross out. So 11 doesn't. 1 plus 3 is 4. That won't work. 1 plus 7 is 8. That doesn't work. 1 plus 9 is 10. That doesn't work. 2 plus 1 is 3. So I know I can cross off 21 because 21 is now a multiple of 3. 2 plus 3 is 5. That doesn't work. 2 plus 7, that's 9. So I cross 27 off. Because when I add those digits together, I can divide that number evenly by 3. 2 and 9 is 11, so I can't do that. 3 and 1 is 4, nope. 3 plus 3 is 6, so 33 goes away. 3 plus 7 is 10, that doesn't work. 3 plus 9 is 12, that does, so I know I can cross out 39. 4 plus 1 is 5, doesn't work. 4 plus 3 is 7. 4 plus 7 is 11. 4 plus 9 is 13, so I haven't crossed any of those off. 5 plus 1 is 6, though, so 51 does work. So 51 is a multiple of 3. 5 plus 3 is 8. That doesn't. 5 plus 7 is 12, so 57 does. So 57 is a multiple of 3. 5 plus 9 is 14. 6 and 1 is 7. Doesn't work. 6 and 3 is 9. So 63 goes away now. 6 plus 7 is 13, so that one's still good. 6 plus 9 is 15, so 69 actually goes away. No. 7 and 1 is 8, doesn't work. 7, guys, if you have a question, raise your hand. Other than that, I should be the only one talking right now. That means you don't talk, Kaylee. 7 and 3 is 10. No. 7, 7, 14. 7, 9, 16. 8 plus 1 is 9. So 81 is actually crossed out now. 8 plus 3 is 11. That doesn't work. 8 plus 7 is 15. That works. So now 87 is gone. 89, that's 17. No. 9 plus 1 is 10. 9 plus 3 is 12. 93 now goes away. 9 plus 7 is 16. Doesn't work. 9 plus 9 is 18. So 99 now goes away. Okay, so now we're down to just a few whites left. We have now taken care of all the multiples of 3 except for the 3. So we're at step 5. We're going to cross off all of the doubles. Most of them have already been done. We're not going to cross off 11, but all the rest. So now we get rid of 77. So that one's added in now for us. Not 11. Right. So we crossed off 77. We're not going to do 11. 11 is actually a prime number. Right. I said cross off all of them except 11. Color everything except 11. Yes.
You're saying two different things here. First you said cross them all out, and then you said color them all.
Crossing them out is coloring them. When we color them, that's crossing them out, guys. We're doing all of them except 11. We changed the word from cross to color. If you look, it's the same. Except for 77.
If you're listening to his directions, you would know.
Okay? Now, last check, number 6, which is not on the board. We added it to the packet when we realized this error, because we haven't actually checked our 7s yet. There are 2 more numbers we're going to cross off because they're factors of 7. That would be the number 49. And believe it or not, the number 91.
Really?
Yep. 7 times 23. No, 7 times 13. Now, what you have left is basically a cheat sheet. All of the numbers that are left in white are your prime numbers. The one thing they all have in common, you cannot divide them by 2, 3, 5, or 7. So, I'm going to read these numbers very quickly. Just check your chart. Make sure you didn't leave any white that shouldn't be. So I'm reading your white numbers. So if you have a number that's white and I'm not reading it, it means you need to color it in. So our prime numbers are 2, 3, 5, 7 in the first row. Next row is 11, 13, 17, 19 should all be white. The next row, 23, 29. Next row, the 30s, 31 and 37 are white. Your next row, 41, 43, 47. The next row, 53, 59. Next row, 61, 67. Next row, 71, 73, 79. Next row, 83, 89. And your last row, 97. So these are all of your prime numbers from 1 to 100. Yes?
I colored it in 71.
I colored in 67. You have white out?
I need white out.
Okay, hold on. I'll have to check. What I need you guys to do right now, though, is... Yes, ma'am. My class isn't doing so well. Oh, if you need white out, go see Mr. Chan. White out. If you messed up your chart, go see Mr. Chan. Guys, turn the page. Okay, we're going to give you guys 3 minutes. You're going to check all 6 numbers. Right, if they are prime or composite. Quick question, does it say write P or C? No, it says write prime or composite for each of those 6. Try to do it without looking back at your chart. I will give you a hint. Your key numbers, 2, 3, 5, and 7, will give you the answers. 2 minutes, go. Okay, this one should have been easy. 35. Can I divide that by 2? 3? 5?
Yes.
As soon as I say yes, it's composite. 2. Number 42. Can I divide by 2? Composite.
Oh, yeah.
Number 3. 29. Can I divide that by 2? 3. 5? 7? Prime. 19. Can I divide by 2?
No.
3?
No.
5?
No.
7? Prime. 130. Can I divide by 2? Composite. 31. Can I divide by 2? 3? 5? 7? Prime. Micah, pull your seat in, sit at your table. I don't think it's me she's looking at. We're both getting a little upset at how bad you guys are being today. Normally on the recording days, you guys are better. This is not good. This is really bad today. I don't know what you guys are doing.
I think you need to move back this way. Can I at least go? Oh, that's awesome.
Okay. We're going to show you 2 ways to do prime factorization. Prime factorization, the definition is breaking down a composite to all prime factors. You don't have to use a factor tree, but you do need to rewrite the prime factorization as a multiplication sentence. When we list the factors in a prime factorization, we normally start with the lowest number and build up to the highest number. We're going to show you 2 ways to do it. Either one is absolutely fine. Okay? The first way is what we call a factor tree. Factor tree is commonly used in prime factorizations. All you do is you break the number and you start breaking it into its component parts. So I start breaking it down to factors. Now, little Mr. Moore hint. I still use 2, 3, 5, and 7 to make it easier for myself. So I just say, can I divide 36 by 2? Yes, so that's the first factor I'm going to list. So 2 times 18 is a factor I can start with. You could do 4 and 9. You could do 6 and 6. Any of those work. You'll get to the same answer. This is just the way I personally prefer to do it. Every time I get to a prime number, I circle it. That tells me that branch is done. It's broken to its prime factors. Okay? 18. Can I divide it by 2? Yes. So that becomes 2 times 9. 2 again is done. Can I divide 9 by 2? By 3? Yes. So that one is 3 times 3. All of my branches are now ending in a circle. Once all my branches are circled, that means I am done. Now all I have to do is rewrite it in a multiplication sentence. So I just start at the lowest factor, 2, and I go 2 times 2 times 3 times 3. I list all of the factors in order, and I multiply them. So if you multiply that out, 2 times 2 is 4 times 3 is 12 times 3 is 36. Okay, we'll finish after. Okay, so right before lunch, we finished the prime factor tree. So I'm going to show you the other way to do this, which is built off of the cake. Madison, we're back in. We need to be paying attention now. Put the book away. Cake, very much the same as when we did GCF and LCM. The big difference when I'm doing it as a prime factor tree is I'm literally just going to go through my 4 key numbers in order. So I start at 36 and I say, can I divide 36 by 2? If I say yes, then I do it. So I divide by 2. I don't know what's going on here with my board. So I divide by 2, I get 18. Each layer, I just ask myself that question again. Can I divide 18 by 2? Yes. So that becomes 9. Can I divide 9 by 2? By 3? Yes, so I do it. 3, 3. Once I get to a layer that has one of my 4 key numbers, or is a prime number, in other words, I can't divide it by 2, 3, 5, or 7, I'm done. Now all I have to do is rewrite this just in the order I listed it. So 2 times 2 times 3 times 3. You'll see it's exactly the same as what we just did. Will either method work? Yes. Okay? Personally, I prefer the cake because it's a lot faster. And it focuses in on those 4 key numbers. Go ahead. Where have you been, Mateo?
That's a sus look you got on your face.
I think I was earlier. Okay. Now, so because I've shown you both, I'm just going to do the one that I like because we're running down on time. Can I divide 70 by 2?
Guys, please stop talking.
Yes. That's 35. Can I divide 35 by 2?
No.
By 3? Are you sure?
No.
What's 3 plus 5? 8. So no, I can't. Can I divide it by 5? Yep. That gives me a 7. So now I'm done. 2 times 5 times 7. See how fast this can go, guys? 45. Can I divide 45 by 2? By 3?
Yes.
Yes. 4 plus 5 is 9, so I can divide it by 3. That's going to be 15. Can I divide 15 by 2? By 3? Yes. 5 is one of my key numbers, so I know I'm done. Is this making sense?
Yeah.
You understand how to break it down? You understand how to rewrite it as a multiplication sentence? Okay. So we want you to practice both. So we're going to use the number 60. Do a prime factorization and a cake. Try both methods. See which one you like better. We'll give you 2 minutes. Hopefully you guys were able to finish both. Let's take a look really quickly. Doing the prime factor tree. Again, you can use any factors you want. I personally prefer to start at 2. So I'm starting the end branches right away. So for me, it's 2 and 30. If anyone did 30 and 30, you're wrong. It's not adding. It's numbers I've multiplied to get to it. So 30, I can do 2 and 15. 15, I can do 3 and 5. So I end up with 2 times 2 times 3 times 5. Cake method, 60 divided by 2, divide by 2, divide by 3, bang, I'm done. So same answer, either way, you can do this.
What if you did 6 and
You can't, guys, Kaylee actually brings up a really good point. She said, what if I use 10? Guys, this is one difference when you're using cake method for prime factorization versus doing it with GCF and LCM. GCF and LCM, I can pull out bigger numbers because I was finding GCF or LCM, which are not necessarily just the prime numbers. However, when I'm doing prime factorization, I can only pull out prime factors. So if there's bigger numbers, don't use them. Literally go through your progression 2, 3, 5, 7. Okay? So good question. Thank you for asking that one. Because I can't have a composite number in my list of prime factors. Make sense?
I hate this.
Okay. So we have 2 pages, page and a part left. I want you guys to finish the bottom part here and all of the rest of the next page. You have 10 minutes. Go. Okay, we're going to go through this quickly because you should be just checking your answers right now. So here's your key. When I'm checking prime composite, all I do is run through my 4 key numbers. Can I divide 23 by 2? By 3? By 5? By 7? Prime. Can I divide 144 by 2? Yes, composite. Can I divide 45 by 2? By 3? Yes, I can. 4 plus 5 is 9.
now. Mr. Moore said not to, but if it continues, I will.
Yes?
Talking to you.
2, then 3, so that's why I said no.
3, it divides by 3. What's 4 plus 5, Madison? 9. I can divide 9 by 3, so I can divide 45 by 3. Now, you probably saw 5 and got there anyway. I'm just trying to get you into this habit of understanding that progression. Okay, 0. That is a neither. Guys, quiet down. 112, I can divide by 2. That makes it composite. 1 is a neither. Guys, seriously, we're down to 7 minutes. We've still got a lot to do. So, that being said, I'm going to fly through this. Again, we should be checking your work. If you didn't do this yet, try and write it down as I'm going. But literally, all I'm going to do is go through my progression. Can I divide 54 by 2? Yes. 27. Can I divide 27 by 2? By 3? Yes. That's 9. Can I divide 9 by 3? Yes. 2 times 3 times 3 times 3. You would have gotten the same thing if you did a prime factor tree. That's fine. But either way, that should be your answer. 21. Can I divide by 2? By 3? Yes. 3 times 7. 24. Can I divide by 2? Yes. 12. Can I divide by 2? Yes. 6. Can I divide by 2? Yes. So 2 times 2 times 2 times 3.
24 at the bottom.
That was 24 at the bottom. That's the number I'm doing.
Oh.
You're right. I did write 24 at the bottom.
Sorry.
Okay, 63. Can I divide that by 2? By 3? 21. 21 divided by 3? 3 times 3 times 7. 40. Can I divide by 2? Yes. 20. Can I divide by 2? Yes. 10. Can I divide by 2? Yes. 5. 2 times 2 times 2 times 5.
Can I show you how one of my kids did? They didn't rewrite the number. They just did the cake on top of the number and kept going up.
That works. You can actually even do it down if you wanted to as well. 2 gives me 21. 3 is 7. Guys, please. Okay, so that should give you all of your answers. Number 7. The only one I should be hearing right now is Miss McShann. Cannon. Now, one big piece on this. Test-taking strategy. It says prime factorization, right? Can I have a composite number in a prime factorization? No. So as soon as I see a composite number, I know that number won't work. Composite number, it won't work. Composite number, it won't work. Did I actually have to do the prime factorization? No. Now, if there had been 2 options, you have 2 ways you could do that. I could do the prime factorization of 750, or I could multiply this out. Either one would show you which one it was. The last one, the idea was to get you to multiply the prime numbers here at the bottom, but you could just do 14 times 20 and you'd get 280. Make sense? Okay, guys, here is your homework. Actually, that's not your homework. That's the answers. Here's your homework. So, guys, please listen. You only have this 1 page of homework for tonight. We start with a word bank. Only 4 words, only 4 blanks. Should make that easy. Then, does it say write P, C, or N? No. So if I write P, C, or N, have I done my homework? No, guys, write it out. Finally, factor the following. You can use any way you want, prime factor tree or the cake method, either works. The value of the expression, that's just saying what does it equal. In other words, multiply this one out. And then what is the prime factorization of 16? Figure out which one of those it is. Pretty easy set of homework. Make sure you bring your packet next class because we are going to finish the rest of this packet. Make sure you bring your new modules as well. We're probably going to be doing some work out of the modules along with the next lesson, guys. Okay, you've got about 3 minutes left. If you wanted, some of you could probably finish your homework in the next 3 minutes if you haven't already.